Welcome to Academic Game Tutorials. In this video we will learn about Electrolux refrigerator, along with its different parts and functions. So, let's get into the topic. The Electrolux refrigerator is also known as domestic Electrolux refrigerator, or we can also call it a 3-fluid refrigeration system. The prime purpose of using domestic Electrolux refrigerator is to eliminate the use of pump in the refrigerator, so that we can eliminate large amount of noise produced by the pump inside the refrigerator, and also we can avoid the moving parts inside the refrigerator. Just now, we said that it can be also called 3-fluid refrigeration system. This is because we are using 3 different fluids in order to run this entire system. The fluids are ammonia, water, and hydrogen. Now, whenever we talk about refrigeration process, the first thing we need is a refrigerant or coolant. We can think of the refrigerant as the messenger or traveler, because this refrigerant is the actual carrier or medium of heat exchange throughout the whole refrigeration cycle. Here, in domestic Electrolux refrigerator, out of the 3 fluids, we use ammonia or NH3 as the coolant or refrigerant. Even though ammonia is toxic, we use ammonia as the refrigerant, because it has most of the desirable properties. And here our second fluid is water. We use water as a solvent here, because it has the ability to absorb this ammonia. So, since ammonia is soluble in water, our coolant ammonia flows through the Electrolux refrigerator system as a mixture with the solvent water, and changes states from liquid to vapor, or vapor to liquid at convenient temperatures for the refrigeration cycle. We use hydrogen because it is a very light gas, and helps to increase the rate of evaporation. It is non-corrosive and insoluble in water. The lighter the gas, the more will be the rate of evaporation. So, these are the 3 fluids that we need to run the whole process. Now, let's look into the major parts and components, and their functions in the domestic Electrolux refrigerator. First of all, here we have a generator. Inside this generator, we have a solution of ammonia and water. Here we have a gas burner. And, using this gas burner, we provide flame and heat to this solution of ammonia and water inside the generator. So, the function of this gas burner is to provide heat to the generator, so that the ammonia and water solution inside the generator turns into vapor. After that, this vapor of ammonia and small amount of water vapor will leave the generator and enter the rectifier through this connecting pipe. The rectifier can also be called water separator. When vapor of ammonia will be formed here in the generator, there will be also some contents or some proportion of water in it. That is, through this connecting pipe we will have ammonia vapor and some H2O or water vapor particles coming into this rectifier. Now, the rectifier separates these water vapor particles from the ammonia vapor. After being separated, these water particles will be accumulated here in this rectifier, and then the rectifier sends this water back to the generator to be reused. Now, from the rectifier, only the pure ammonia vapor will be passed forward and sent to the condenser through this connecting pipe. This condenser can be water-cooled, or cooled by any other substance from an external source. When high-temperature ammonia vapor enters this cold condenser, then the condenser absorbs the heat from the ammonia vapor and converts it into liquid ammonia. So, the purpose of the condenser is to condense the ammonia from vapor to liquid. Now, this liquid ammonia will leave the condenser and enter into the evaporator through this connecting pipe. Here, the liquid ammonia will extract all heat present inside the evaporator and generate the cooling effect or refrigeration effect. But, here inside this evaporator, one more fluid will enter into the process, which is hydrogen gas. Now, from where are we getting this hydrogen gas? If we see, here we have an absorber. In the lower portion of this absorber we have water, and in the upper portion of the absorber here we have hydrogen gas. As we already know, hydrogen gas is insoluble in water, and it is lighter in weight, so, the hydrogen gas remains in floating condition in the upper portion of the absorber above the layer of water. And, since hydrogen gas is very light, so it will go through this connecting pipe and enter the evaporator. Here, in the evaporator the hydrogen gas will mix with this ammonia liquid and increase the rate of evaporation, thus the cooling or refrigeration effect will also increase due to addition of hydrogen. Again, After extracting heat from the evaporator, the ammonia liquid will turn into ammonia vapor, then both ammonia vapor and hydrogen leaves the evaporator, and enter into the absorber through this pipe. Now, we already have water inside the absorber, and we know that ammonia is soluble in water, so, the ammonia vapor gets mixed with water, and forms ammonia-water solution. But, since this hydrogen is insoluble in water, it will again go upwards, and from here it will again go into the evaporator. And mixing with ammonia liquid it will do the refrigeration effect. Then again both ammonia vapor and hydrogen comes to the absorber. Ammonia vapor forms mixture with water, and hydrogen gets separated over here, and this goes on continuously. After that, connected to this absorber we have a heat exchanger over here. As we know, the heat exchanger is used to exchange heat from the hot body to cold body, and from cold body to hot body. So, this strong ammonia-water solution from the absorber will now enter into the generator after passing through this heat exchanger. Now, this strong solution needs to be hot before going into the generator. So, here through another pipe, the weak high-temperature solution from the generator passes through this same heat exchanger and goes into the absorber. Thus, what actually happens inside this heat exchanger is that, this weak but hot solution gives away heat to the heat exchanger, and becomes cold before entering the absorber. And over here, this strong solution coming from absorber will enter the heat exchanger and absorb the heat given away by this weak solution. Thus the weak solution becomes comparatively cold and enters absorber, and this strong solution becomes comparatively hot. And then this comparatively hot strong ammonia-water solution enters the generator. And thus the whole cycle goes on again and again, and refrigeration goes on continuously inside this evaporator. Thus cooling effect keeps happening in the Electrolux refrigerator, or the domestic Electrolux refrigerator. Thank you for watching this video. If this video was helpful, subscribe to my channel Academic Game Tutorials for more updated videos.